When you first learn about arithmetic, you learn how to combine numbers and operators together into a valid expression. So for example, 2 plus 4 plus 6 is a valid expression, whereas times 0, 1 left bracket plus 3 divided by is not a valid expression. So, we're going to learn how to do this with Boolean logic. First, we need to learn about recursion. So, recall arithmetic sequences, the ones you did in elementary school, where you'd start with some base number and then you'd increase by some other number for each step. In this case, we have the sequence 1, 3, 5, 7, 9. So we start with 1 and increase by 2 each time. Now suppose x is the nth term of the above sequence. What is the previous term written in terms of x? Well, since the sequence increases by 2 each step, it's pretty obvious that the previous term is just x minus 2. And you can pick any number in the sequence and you can verify. Okay, so, let's pick 9. So 7, yes, this is 9 minus 2. 5 is 7 minus 2. 3 is 5 minus 2. And 1 is 3 minus 2. And it's this kind of thinking where you start with some number and then by recursion, you eventually get to 1. This idea will be helpful when defining how to write valid Boolean expressions. So here's our base. If p is a propositional variable, so true or false, then p is a formula, which is a valid Boolean expression. Further, if phi sub 1, phi sub 2, ... phi sub n are all formulae, then the following are true. Not phi of 1 is a formula. Remember, not turns phi sub 1 into true when phi sub 1 is false, and phi sub 1 into false when it's true. Phi sub 1 and phi sub 2 and ... and phi sub n is a formula. Similarly, any finite combination of the phi sub i's and the OR operator in this form is a formula. So basically this is a binary operation which is associative. Phi sub 1 implies phi sub 2 is a formula. Now note that this is not associative. This is a binary operation that only works on 2 formulae. And phi sub 1, if and only if phi sub 2 is a formula. We'll take this knowledge that we have and run through some examples. So, P, Q, R, and S are propositional variables, which are the following are formulae. We'll look at the first one. P left bracket implies true not. This doesn't follow any of the rules that we've gone over, so this is not a formula. P implies not true. Okay, well, P is a formula, and true is a formula. So not true is a formula, so P implies not true must be a formula. So this is a formula. P implies Q implies R. Okay, well, our rule here states that we can only have 2 formulas combined together with this implies. So this is not a formula. And lastly, P implies Q implies R. This is like a fix of what we have above. Okay, so Q and R are formulae. So Q implies R is a formula. So since P is a formula, P implies Q implies R is a formula. And for the last example, I am going to hand it to you as an exercise. That's all for today's video. Thanks for watching.